Good morning. Today is September 30th, 2020. It is Wednesday. And our I Can for today says, I can add using subtraction to check. And we all know that's called the inverse, right? It's the opposite operation. Okay, well, before we get into that, let's refresh on our fact families. I'm going to give you a fact family. I went down 4 lines, of course, right across, and closed in my box. Today's fact family is only going to have 2 numbers in it and a letter. That's a P. And I know some of you are thinking, oh my goodness, that looks so hard. Guys, this is using algebra, and it's not that hard. But right now, we're not even going to solve for it. I just want to see if you know how to make the fact family. So I'm going to tell you the very first fact. I'm going to tell you that 17 times 6 equals P. Well, that's good. Who can give me the next fact? We're going to use the commutative property. If you said 6 times 17 equals P, you're exactly right. Nice job. Now, if these are my factors and this is the product, which number am I going to start with first when I do my division? I'm going to start with the P. P, for both of these actually, P divided by 6 will give me 17, and P divided by 17 will give me 6. Now we know that 2 of these are commutative, and 2 of these are not commutative. Commutative means that they just switch their order, but the answer stays the same. If it's not commutative, it means I can't just switch the order. And this is always the case for division or subtraction. So let me give you one to try by yourself. I'm going to make the house right next to it. See if you can fill in the fact family. Our facts are going to be 8, 5, and M. You could use any letter you like. I'm going to give you the first one. I want you to do the last 3. I'm going to tell you that 8 plus 5 equals M. Go ahead and press pause on the video and solve the rest of the fact family. All right. So if I know 8 plus 5 equals M, well then 5 plus 8 equals M. Then I know that M minus 5 equals 8 because subtracting is the inverse to adding. And M minus 8 equals 5. We have 2 that are commutative and 2 that are not commutative. If you always do your adding and your multiplying sentences first, it will help you remember this. The 2 on the top are both commutative. We can switch the order around, the answer will always be the same. But the 2 on the bottom are not commutative. We cannot just switch the order around. All right, that's a good review, and now we're not scared of using letters instead, doing a little bit of algebra in our fact family. So let's go ahead and do an example for today. Today we're going to be adding and using subtraction to check. This means any question that you turn into us, you will already know that you got it right because you've already checked it. And yes, we expect you to do that on every single question. So here we go. Here's our first example for today. Our number is 3,134 plus 2,496. I'm going to add those two together. Now, we talked a little bit about it earlier when we were talking about place value. There's always this invisible decimal point at the end of your number. It seems not important for right now, but it will be later this year, so let's get in the habit of writing it. We always make sure our decimals are lined up at the end. And look, all of my numbers are matched up with a buddy, and even my commas are in a line. Everything needs to be really neat with your math notes. What is 4 plus 6? If you said 10, you're right. Am I allowed to put a 10 down here? No, we learned that with our place value chart. We can only put one digit in each place. So my 0 goes down here and I carry my 1 next door. So now I'm looking in this place. 9 plus 3 is 12, plus one more is 13. Can I put 13 down here? No. The 3 can stay, but just like we practiced in our place value, we have to carry that 1 next door. So now we're here. What is 4 plus 1 plus 1? 4, 5, 6. 6. Am I allowed to put a 6 down here? Yes, because it's only one digit. And then what's 3 plus 2? If you said 5, you're exactly right. So read this number out loud. If you said 5,630, you're exactly right. Now, we want to be sure before we turn this in, so look what we're going to do. I'm going to draw a little arrow up to the top, and we're going to do the inverse operation to check. So only these three numbers can be used. I'm going to write 5,630 on the top. Now, what's the inverse of adding? The opposite is subtracting. I'm going to write this number right across there. 2,496. And I hope to come up with this top number, but we have to actually subtract it to see. What is 0 take away 6? Well, I can't do it. So I have to go next door. Neighbor, neighbor, can I borrow one? They say, sure. You have the friendliest neighbors ever. And when I bring them back with me, because we're changing place values, I brought back 10. Can I do 10 minus 6? I get 4. 2 minus 9. If you have $2, can your little brother take away 9 of them? No. So you have to go next door. Neighbor, neighbor, can I borrow one? Sure. Now they only have 5. But we brought back 10. 10 plus 2, now we have 12. What is 12 take away 9? 3. What's 5 take away 4? 1. Our commas lined up. And 5 take away 2 is 3. 3,134. 3,134. Guys, we got it right. If I was doing a tape diagram for this one, I would have shown my two amounts that I was putting together, and we would have been looking for the total because we didn't know what the total was. And I had 3,134, and I added 2,496. And that was going to give me my mystery number, which we found right over here. Then I checked it, and I took the total and I subtracted one side, and that's how we got this. All right, I'm out of room, but we're moving on to number 2. So I'm flipping to the back of my notebook page. Please make sure you're using the front and the back of your notebook pages. It helps us save paper. All right. Mr. Robeson biked 907 miles the first week. Mr. Robeson biked 297 more miles the second week. Now, this is a really tricky one, and that's why we're starting with one like this, so you can kind of make sense out of it. Let's think about this for a second. Did Mr. Robeson bike more the first week or the second week? It says he biked 907 miles the first week. It says he biked 297 more miles the second week. So is the first week going to have a longer box or the second week? If you said the second week, you were exactly right. That second week has to be longer. So we know that the first week he rode 907 miles. The second week, he rode 297 more miles. He rode 297 more miles in the second week. So we know the first week is this. We know this is 297 more than that. So look, I made the wrong tape diagram. I'm going to erase this tape diagram. I have to use 907 and add 297 to it. And when I get this number, what will that give me? Is that going to give me my answer to how much he biked in total? No, this is only going to be my answer to week 2. We don't know how much he biked in week 2. All right, so let's add them together. 907 plus 297. What's 7 plus 7? 14. Can I write it just like that? No. So I have to carry the 1 next door. What's 9 plus 1? 10. Am I allowed to do that? No. So the 0 can stay, but my 1 has to be carried next door again. 9 plus 1 is 10, plus 2 more is 12. 1,204 miles. Is that total? No, that's just the second week. Now, if our question asks us, how many miles did Mr. Robeson bike in all? What would I need to do with my numbers? Absolutely, I need to add them together. So I have week 2. This is the second week down here. This is the first week up there. Do you know what a too fast fourth grader would have done? A too fast fourth grader would have said that this was the answer. But it wasn't. So let's be very careful. How many miles did Mr. Robeson bike at all? We're going to take week 1 plus week 2, and that's going to give us our total. So the first week he rode 907 miles. The second week he rode 1,204 miles. If it's hard for you to stack them like this with the larger number on the bottom, you can always change the order because it's addition, and addition is commutative. You can change it however you like it. What's 7 plus 4? 11. So 1 goes down and I carry my other 1. What's 1 plus nothing else? 1. It's 9 plus 2 is 11. Can I put 11 down here? Nope, just 1 down and 1 up. 1 plus 1 is 2,111 miles total. Well, that's what we think. We do think this is our answer, but we have to check. So I'm going to rewrite my number on top, 2,111, and I'm going to subtract 1,204. What is 1 take away 4? I can't do it, so I have to go next door. Neighbor, neighbor, can I borrow 1? Sure. Now they have none left. And I brought 10 back with me. What's 10 plus 1? 11. What's 11 take away 4? Is 7. Now I have 0 minus 0. Well, it gives me 0. What about 1 take away 2? If you have 1 donut, can we take 2 of them away? Nope. So you have to go next door. Neighbor, neighbor, can I borrow 1? Sure. And I bring back 10 with me, but I already had 1, so what's 10 plus 1? 11. So 11 take away 2 is 9. And 1 minus 1 is 0. I could put it out here or I could not. 907 matches 907. We know that we got this one right. So this is not terribly hard. Let's go ahead and just write this into a fact family. What I did was I did 907 plus 1,204, and I got 2,111. Sorry about that. The next fact in my fact family would be 1,204 plus 907 equals 2,111. Now, when I'm setting up my subtraction, I always have to use the biggest number first. 2,111 minus 907 equals 1,204. 2,111 minus 1,204 equals 907. And we're done. Not so bad. Take your time. Make sure to check each of your answers today before turning in your work. Have a good day.